Alright, so here we go, 5.1, day number 2 more with antiderivatives. I'm going to use the power rule here in order for me to come up with the antiderivative. So I'm going to use a couple of shortcuts here. We're going to go like this, and that will give us big F of x, which will be 3 times x to the 5th over 5 plus c. This is a good one. Good old x plus c. And this is a peculiar one. You don't actually want to use the power rule on this one. I would just recognize the integral of 1 over x dx, which you may also see in this form, dx over x. This is going to be the natural log of the absolute value of x plus c. Alright, so why the absolute value? Well, that's just to ensure that the domain is what the natural log has, right? So in 1 over x, right, its domain is all real numbers except for 0. So negative infinity to 0, and then 0 to infinity. We do the absolute value here to ensure that the domain is just x greater than 0. So you're going to want to memorize the following. This will be natural log of the absolute value of x plus c. This will be sine of x plus c. This will be tangent of x plus c. Remember, these are to be put to memory. This would be e to the x plus c. That's a nice one. This would be negative cosine of x plus c. And this would be x to the n plus 1 over n plus 1 plus c, provided that n does not equal negative 1, because then we would be back in that situation there. Alright, so determine the following indefinite integrals. Okay, so some of this is intuitive in nature. You're just going to have to kind of work your way backwards and maybe take the derivative. Right, the derivative of that would come out to be that, e to the 3x, therefore we're good. So e to the ax will always be 1 over a e to the ax plus c. Alright, just a general formula there. Alright, so recall that 3 to the 3x squared was x cubed plus c. Okay? What if I want the particular solution, right? So for example, the solution passes through 1, 4. So let's try to find the solution for big F of 1 equal to 4. Well, what you'd do, right, is you'd go ahead and you'd have x cubed plus c, which is big F of x, right? Okay, so then let's find c by using what we know. Well, big F of 1 equals 4, so 4, right, 4 equals 1 cubed plus c. Therefore, it looks like 4 minus 1 equals c, so c equals 3. So we know the exact solution now. The integral of 3x squared plus, dx equals x cubed plus 3, provided that the function passes through 1, 4. So find the antiderivative of f that satisfies the given condition. Okay, so we know that big F of t will be tangent of t. So if f of pi over 4 equals 1, well, the tangent of pi over 4 is 1, so 1 equals 1 plus c, therefore c equals 0. So big F of t in this particular situation with that solution would just be tangent of t. c is 0. All right, let's use the following. So if f is this, and big F of 1 gives us 1/3, then what we'll do is we'll take the antiderivative of this, so big F of x will equal x cubed over 3 minus x squared. Derivative of that, yep, that would work out. So big F of 1 equals 1/3. So 1/3 equals 1 cubed over 3 minus 1 squared. Don't forget plus c. Alright, so let's solve. Okay, so this is 1/3, this is 1/3, this is -1, and this is c. So it looks like I have 1/3 is equal to -2/3 plus c. Therefore, I would add 2/3 to both sides, and I'd get c equals 1. So with this solution, big F of x would equal x cubed over 3 minus x squared plus 1. Alright, here's a challenge. What would be the integral of v of t? Well, it'd be x of t plus c. Right, x of t being the position. Right, another way you could write that is s of t plus c. What is the integral, indefinite integral of, or the antiderivative of acceleration? Well, the antiderivative of acceleration would be velocity plus some constant. Alright, so let's say v of t equals 6t squared plus 4t minus 10, and s of 0 equals 0. Alright, so then big S of t would equal 2t cubed plus 2t squared minus 10t plus c. So s of 0 equals 0. So if I plug a 0 in for each of these values, it looks like I get that c equals 0. So find the position function. So then s of t would equal 2t cubed plus 2t squared minus 10t, and of course, since c is 0, I'd be done right there. Okay, so let's say velocity function is 1 over t. Then capital S of t would equal the natural log of t plus c. Right, 1 over t would be the same as 1 over x dx. Right, so the integral of 1 over t dt would equal natural log of t plus c. Right, so if s of 1 equals 4, if I plug a 1 in here, the natural log of 1 is 0. Therefore, 4 equals 0 plus c, so c equals 4. So s of t, that's big S of t, would equal the natural log of t plus 4. Alright, here's a good one. Alright, acceleration is 2 cosine of t. Alright, so the velocity, big V of t, alright, would be, looks like 2 sine of t plus c. The position, okay, hold on, let's work this out. So v of 0 is 1. So v of 0 is 1. Alright, so sine of 0 is 0, 2 times 0 is 0, plus c. So our velocity function would equal 2 sine of t plus 0. Okay, so then our position function would be the integral of that, which would be negative 2 cosine of t plus c. Right, because the integral of 2 times the integral of sine of t dt would equal negative 2 cosine of t plus c. So if x, and I guess I could go with s or x, the position function is 0 when we plug in a 0. So that's negative 2 times the cosine of 0. Cosine of 0 is 1. Okay, plus c. Therefore, c would equal 2. So our position function x of t would equal negative 2 cosine of t plus our constant 2. There's our position function backing up through the velocity function from the acceleration function. Alright, a particle moves along the x-axis with a velocity of that for time t greater than or equal to 0. If the particle is at position x equals 2 at time t equals 0, what is the position of the particle at t equals 1? Alright, so what I'm going to do is I'm going to integrate the velocity function. So I'd have t cubed plus 3t squared plus c. It says if the particle is at a position of x equals 2 at time t 0, right? That means that at t equals 0, x equals 2. So t equals 0 is our independent variable. So at t equals 0, well, this would be a 0, this would be a 0, that'd be c, right? So 0 plus 0 plus c. So it looks like c equals 2. So our position function would be t cubed plus 3t squared plus 2. It says what is the position of the particle at time t equals 1. So x of 1 looks like it'd be 1 cubed plus plus 3 times 1 squared plus 2, which would be 1 plus 3 plus 2. Position at time 1 would be 6. Alright, let's look at another one. Ooh, way back to 98. Alright, a particle moves along the x-axis, so its position at time t is given by that. For what value of t is the velocity of the particle 0? Alright, so this is not an integration problem, this is a differentiation problem. So that would be 2t minus 6 is the velocity function. Therefore, our velocity, we want to know when our velocity or our derivative would be 0. And that looks relatively easy, that's almost sneaky. Am I doing something wrong here? I don't think so. Alright. Last question. At time t is greater than or equal to 0, the acceleration of a particle moving on the x-axis is given by that. At t equals 0, the velocity is that. So velocity of 0 equals negative 2. For what time t will the velocity of the particle be 0? Okay. Alright, so let's take the integral of t plus sine t dt, right? That's the integral of our acceleration function with respect to t, and that should give us our velocity function. All right, our velocity function would be t squared over 2 minus cosine of t plus c. All right. So the velocity of the particle is negative 2 when t equals 0. When t equals 0, well, that would be 0. When t is 0, that would be 1. So it looks like negative 1 would equal c. Okay, so this is calculator allowed. I might run into an issue, but we'll see. So we want to know when the velocity would equal 0. Well, I know it would be t squared over 2 minus cosine of t, and c is equal to negative 1. I want to know when that's equal to 0. Yeah, that's definitely going to require a calculator. I guess I was a little overconfident there that I could do some work. Alright, so I'll come back with an answer after I check with my calculator. Alright, my calculator gave me 1.478. So it looks like when t equals 1.48, the velocity equals 0. So the velocity when t equals 1.48 equals 0, meaning that the the particle has come to rest. All right, that's 5.1, day number 2. More with antiderivatives.